Before we get started with section 2.7 on the homework, I would like to take the time to go over some of these basic transformations. You can take any basic function, tweak it a little bit, and come up with a brand new graph that is a transformation of the original graph. Now, once you get the hang of how to spot these, you don't even need a calculator to determine how the new graph is going to look. For example, we want to graph our basic function f of x is equal to x squared. We did this in the previous section, so you can review your notes for there. But to save time on this tutorial, I'm going to use a graphing calculator. When I enter a graph y equals x squared for the function f of x equals x squared, you get our basic parabola. Now we can transform this in many ways, and we're going to start off by taking our basic function x squared and adding 4 to it. Now I want you to make a guess as to what type of transformation is going to occur. Now several things could happen. This parabola U-shape could move to the right, it could move to the left, it could shift up, it could shift down, it could become wider, it could become more narrow, it could even flip upside down. So I want you to make a guess as to what is going to happen if you take this basic function x squared and add a 4 to it. Now make your guesses, and then what I'm going to do is then keep the original equation in y1 using a thick line for the original equation. I'm going to change to a thick line. And then the new equation, the transform equation, I'm going to put in the y2 position. And we're going to see what happens when you take x squared and you add 4 to it. Make your guesses first, and then I'm going to show you what the graph looks like. There's your original graph, and that's your transformed graph. See this thin line? The thin curve is the transformed graph. The actual transformation that occurred was that the parabola, so the transformation that occurred with our basic function was that it was transformed by shifting the entire graph up 4 units. Okay. Now what do you think will happen to the next graph? I want to compare it always back to the original graph, so I'm going to go to clear what I have in y2. Going back to the basic graph, what do you think is going to happen when you graph a new equation, f of x equals x squared minus 3? Make your guesses, and then I'm going to sketch x squared minus 3, and I want you to see the comparison. The original graph is the dark line. The new graph, x squared minus 3, has been transformed by shifting the entire graph down 3 units. So this, once you get the hang of this, it ends up being a really quick way of creating these new graphs if you know the basic one and know how just changing the numbers a little bit can transform the equation. Looking at the third example here, I want to clear what I have here. And looking at our basic graph of y is equal to x squared, what do you think is going to happen when we put x minus 2 in parentheses and then square it? Going to the y equals, keeping the first one x squared, I'm going to put in parentheses x minus 2 squared. What do you think is going to happen? Don't cheat here. I want you to make a guess. Now view the transformation. Look at this new graph has actually been shifted to the right 2 units. You may have guessed that it's going to shift to the left or down, but this type of transformation, when you see it in the parentheses, is going to do the opposite. In this case, it's shifted to the right 2 units. Okay, make your guesses for the next one. What do you think is going to happen when we compare the original graph with x plus 5 in parentheses and you square it? Make your guesses, and let's look at the transformation. the original parabola and the new parabola. The x plus 5 quantity squared in parentheses has been transformed the original by shifting it to the left 5 units. So anytime you have a number on the outside, like the first two examples, that's going to shift the graph up or down. Anytime you have a number inside the parentheses, it's going to shift it to the right or to the left. Now take a look at the next example and make your guesses as to what type of transformation is going to happen when you have x minus 3 in parentheses, and then outside of the parentheses you have minus 4. Make your guesses and then look at the graph. And the original function x squared, and then the brand new function x minus 3 squared minus 4. That minus 3 on the inside has created the transformation by shifting it to the right 3 units. And then the minus 4 on the outside has shifted the whole thing down 4 units. So the type of transformation here is actually two transformations. The whole graph has been shifted to the right 3 units and then shifted down 4 units. So again, once you get the hang of it, it's a real quick way of determining these types of transformations. For the next one, we are looking again at our basic y equals x squared graph. And now instead of adding or subtracting something, we're multiplying by a fraction in front. So in the second equation, I'm going to enter the fraction 1/2. Put that in parentheses, and then x squared. What do you think is going to happen? Make your guesses, and now take a look at the graph. The new graph has been transformed. That 1/2 out in front has actually made this parabola wider. That's a type of transformation that results when you multiply the basic function x squared by 1/2. It actually makes it wider. Now let's see what happens if we multiply that basic function of x squared and we multiply it by a 2. What do you think is going to happen? Is it going to get wider? Is it going to shift up? Is it going to shift down or right or left? Make your guesses. And now check your guesses to see that the transformation when you multiply by 2 actually makes the graph more narrow. We call that a vertical stretch. It's stretching it up. So in the case of the parabola, the graph becomes more narrow. And then when we have the function y is equal to x squared, and we want to compare it to the new function with a negative out in front, what type of transformation do you think is going to happen? Is this graph going to go up, down, right, left? Is it going to get wider? Is it going to get more narrow? Make your guesses, and now let's see what type of transformation occurs. Did you guess that? The graph has actually been transformed by reflecting across the x-axis. It flips the graph down. So you can use your own words here. You could say flips down, or you can say it reflects across the x-axis. It changes the parabola from opening up to opening down. Now in the last example here, we want to look at our basic function and see what kind of transformations result when you have a 2 out in front and you have a +1 in the parentheses squared and a +3 on the outside. This one's going to have 3 different transformations. That 2 out in front is going to affect the shape of the graph. The +1 is going to affect the graph, and the +3 is also going to affect the graph. Let's take a look at what happens when we compare this new equation with the original. Make your guesses, and we'll see that this graph has been transformed. That 2 out in front actually makes the graph more narrow. the plus 1 has been shifted to the left 1, and the plus 3 has been shifted up 1. So the combination of those transformations, it becomes more narrow. We call that a vertical stretch. The whole graph has been shifted to the left 1 unit, and the plus 1 means that the graph has been shifted up 3 units. So that combination, 3 different transformations, result from here. So when you practice these, hopefully you'll be able to do these without a calculator, just by looking at the equation and identifying the types of transformations that occur.